Okay, good morning, everyone. So it's my great pleasure to talk about Evaluator systems that we built for this benchmark on behalf of the AI Risk and Reliability Working Group. It's my pleasure to introduce Ryan, Kurt, Tyler, Shachi, Rajat, and Rajat Ghosh, and Saurav, who worked with me in this development. So we will start with explaining what evaluators are. So as we've heard before, any benchmark has some fundamental components. We start with, in this particular benchmark, we start with taxonomy and set of guidelines that assesses whether a particular hazard is violating or non-violating. We also have another component, which are the prompts that are uniformly distributed across different hazard categories. We have a grading system that assesses the hazards and produces a final grade or a final score or a report to the system that's being tested. And one of the more fundamental components is the evaluator. That actually is an automated system that assesses whether the system being tested is producing something that is unsafe or safe. So if we look at the flow of the data or risk, what have you, so if we look at the data flow or risk flow, the first component is prompt and taxonomy. That gets fed into the system under test, or the system being tested. In this case, it's an LLM that produces a response to the prompt based on the taxonomy that the prompt adheres to. The system under test produces a response, and the response then makes its way to the evaluator. The evaluator produces labels, whether the particular response is safe or unsafe, and if the response is unsafe, it produces a set of hazard categories that are violated for that particular response. The safety labels then makes its way to the grading system that produces the final score, and that's the report that's going to be made available to the systems that are being tested. So when we designed this evaluator, we had to keep in mind certain design principles. So we wanted to have evaluator model backbones that are not developed by one organization or does not support just one model backbone. We wanted to include machine learning backbones from various different organizations so that it's neutral and the neutrality is taken care of at every step in the process. We also wanted to look at what data was used to train these models and what the data provenance looks like. We wanted various different model backbones produced by different model providers. We wanted to create evaluator systems that can be competitive with state-of-the-art. In fact, we wanted to advance the state-of-the-art in the data and the data distribution that we are interested in for the metric of interest that we are tracking. And we also wanted to not have a single point of failure in the entire system. We wanted multiple evaluators to diversify the risks. So keeping those design principles in mind, we had this development strategy. So if that's the flow of the data or risk, and that's the evaluator, we looked at the whole spectrum. On one end of the spectrum, you can have an evaluator who's a human who looks at the responses and assesses whether it's safe or unsafe. Now, obviously, doing that for every single such response and every single prompt is not scalable. Also, human annotations have been shown to be inconsistent at times. It's also not very flexible. So on the other end of the spectrum, we can look at automated systems or machine learned systems. We have pre-trained models that are available off the shelf, a lot of LLMs, as we know, or even safety models like LlamaGuard, WildGuard, and many other safety models. These are trained on either synthetically generated data or open source data sets. Now, the problem with those models is that they will not produce the exact same measurement or score on our metrics of interest because they are not super performant. They have been trained on trained with different taxonomy. So we wanted to take the middle ground where we fine-tune our own custom evaluators using our own data and our own taxonomy, but also leverage the other end of the spectrum. We wanted to leverage pre-trained model backbones. We wanted to look at synthetic data and the quality that it brings with it. We also wanted to look at human annotations and obviously the quality that it brings along with it. So now training an evaluator is not a trivial task. One of the most fundamental problems in training a model is the training data set. Now, AILuminate has this amazing set of prompts that comes with it, but we don't have the responses. Now, if we're training a model that can judge the safe and unsafe characteristic of a response, we need both prompts and responses. So we need to be really careful on how we generate the responses, what are the system under test or LLMs that we choose to then produce the responses. These system under test would be very different from the ones that are being tested once the benchmark is released, because we wanted to have unsafe responses in the training data set, because then the model will know how to judge between safe and unsafe. So therefore, it was also interesting to elicit unsafe responses from LLMs. A lot of the LLMs are now currently safety aligned, so they won't produce unsafe responses. So we had to think out of the box of how we generate unsafe responses for our training data set. Additionally, we wanted human annotations, but we know that human annotations takes time and it's risky. So we wanted to, in the absence of human annotations, we wanted to look at synthetic labels so that we can make progress and iterative developments while we wait for the human annotations. Now, how do we measure the evaluator? We need to evaluate the evaluators. So we needed a human annotated, high quality ground truth data set, and we also needed a metric that we would track. Now, as we know that a lot of these LLMs are considered very safe unless you elicit certain responses in certain type of prompts and malicious prompts. So we wanted to build evaluators that if a certain response is unsafe, the evaluator doesn't make a mistake. And so we wanted to actually optimize on the false safe rate so that the evaluator doesn't accidentally make a mistake on classifying an unsafe response as safe. So that was our metric of interest. So now, with those, we wanted to track the milestones that we've achieved. We started off with version 0.5 evaluator back early this year, and that was a pre-trained off-the-shelf evaluator that did not use MLC's own data set and did not use, obviously, the version 1.0 taxonomy. So we started with pre-trained state-of-the-art LLMs and safety models. And what we did is we prompt engineered these models with our version 1.0 taxonomy and tried to get the responses and measure the responses and the scoring on those responses. What we found is that those models were not performant on the metric of interest if you just take the off-the-shelf safety models or LLMs. So therefore, we decided to fine-tune our own custom evaluator models using the data set that we have and we have curated using prompts, responses, and safety labels. And doing that allowed us to actually achieve the kind of false safe rate that we were interested in. Eventually, we did have the human annotations, and we are currently training models that are being trained on these human annotations, and we will push those models out going forward. So as we wanted to avoid a single point of failure, we created an ensemble of individual evaluators. So each of these evaluators, those were fine-tuned or prompt engineered, became a part of an ensemble. And the ensemble then produces a final label. Each evaluator produces a safe or unsafe label. It goes to the ensemble logic, and the ensemble actually takes all those labels and produces a final label. And now, if the final label is inconsistent, we send that label for human review and then finally produce the outcome, which is the final label for that response. So I think we believe we have achieved what we set out to do. In comparison to the previous versions, we've now built a fine-tuned evaluator model that has a configurable metric that we can track. We have diverse model backbones so that we're not reliant on one single model backbone. We have an ensemble of evaluators, which is scalable and configurable, and we have achieved a false safe rate that is significantly lower than the state-of-the-art, so we have pushed the state-of-the-art on our own data and our own taxonomy. Of course, it's not perfect, but we're going to keep iterating and producing better models as we go ahead. With that, I would like to thank all the contributors of Workstream 3, engineering, and the entire MLCommons, without whose help this would not have been possible. So thank you so much. It's been my privilege working with all of you.